Space travel on a budget. Who needs gas stations anyway? Imagine embarking on a journey where pit stops for refueling are not an option. Welcome to the world of space travel. Space is big, really big. It's so vast that it defies our everyday understanding of distance and size. You just won't believe how vastly, hugely, mind-bogglingly big it is. The distances are so immense that they stretch our imagination to its limits. And getting around this cosmic playground isn't exactly a walk in the park. Navigating through space requires meticulous planning and a lot of resources. It takes a lot of fuel, and fuel is heavy. Every kilogram of fuel adds to the weight, making the journey more challenging. Carrying all that fuel is expensive, and nobody, not even NASA, likes an outrageous gas bill. The cost of launching and maintaining fuel in space is astronomical. So how do we explore the solar system without breaking the bank? How do we make these long journeys feasible? Enter the ingenious concept of gravity assists, the ultimate cosmic fuel-saving hack. This technique leverages the natural forces of the universe. Think of it as hitchhiking across the galaxy, but instead of relying on the kindness of strangers, we use the gravitational pull of planets. It's a clever way to gain speed and change direction. It's like getting a free tow from Jupiter, except Jupiter doesn't know you're using it. Shh, don't tell. This method allows us to conserve precious fuel. This clever technique has allowed us to send spacecraft on incredible journeys to the far reaches of our solar system and beyond, all while keeping the fuel costs down. It's a game changer in space exploration. So how does it work? When a spacecraft approaches a planet, it falls into the planet's gravitational field. This interaction is carefully calculated to maximize efficiency. As it gets closer, the planet's gravity pulls the spacecraft, accelerating it and changing its trajectory. This maneuver is both an art and a science. The spacecraft then slingshots around the planet, gaining speed and altering its path without using additional fuel. It's a brilliant use of natural forces. This technique has been used in many successful missions. It's a testament to human ingenuity and our ability to harness the universe's power. For example, the Voyager missions used gravity assists to visit Jupiter, Saturn, Uranus, and Neptune. These missions have provided invaluable data about our solar system. The Galileo spacecraft used gravity assists to reach Jupiter, performing multiple flybys of Earth and Venus. Each flyby was a carefully planned maneuver. New Horizons used a gravity assist from Jupiter to speed up its journey to Pluto. This allowed it to reach its destination much faster than it would have otherwise. So buckle up, space cadets, as we delve into the fascinating world of gravity assists and discover how we use the universe's own forces to explore the cosmos. It's a journey of discovery and innovation. It's a wild ride, full of physics, ingenuity, and a dash of cosmic humor. The more we learn, the more we realize how much there is to discover. Get ready to have your mind blown, or at least slightly nudged in the direction of scientific enlightenment. The universe is full of surprises and wonders. And hey, if you ever find yourself lost in space, remember, gravity is your friend. It's the invisible hand that guides our journey through the stars. Gravity, that invisible force that keeps our feet firmly planted on the ground, is one of the most fundamental forces in the universe. It's what makes apples fall from trees and keeps the moon in orbit around Earth. But gravity isn't just about holding things down. It can also give you a serious speed boost if you know how to play it right. This is especially useful in space travel, where every bit of speed counts. That's the basic idea behind gravity assists, also known as gravitational slingshots. Imagine a spacecraft approaching a planet. As it gets closer, the planet's gravity pulls it in, causing it to speed up. This is where the science happens. As the spacecraft gets closer, the gravitational pull becomes stronger, accelerating the spacecraft even more. This increase in speed is crucial for missions that need to cover vast distances in space. By carefully adjusting its trajectory, the spacecraft can swing around the planet like a ball on a string, stealing a bit of the planet's orbital energy in the process. This maneuver requires precise calculations and timing. By doing this, the spacecraft not only avoids getting trapped, but also gains a significant speed boost. This technique has been used in many famous missions, including the Voyager and Cassini missions. The result? The spacecraft gets flung off in a new direction with a significant speed boost, all without burning a single drop of fuel. This is incredibly efficient and allows spacecraft to travel further and faster than they could with just their onboard propulsion systems. It's like getting a free cosmic energy drink, making space exploration more feasible and exciting. Gravity assists, or gravitational slingshots, have played a pivotal role in the history of space exploration. The concept was first proposed by the Italian scientist Giuseppe Colombo, who suggested using Venus to assist the Mariner 10 mission on its way to Mercury in the 1970s. This groundbreaking idea turned out to be a game-changer. By leveraging the gravitational pull of Venus, Mariner 10 was able to reach Mercury with much less fuel than originally anticipated. Since then, gravity assists have been used in numerous high-profile missions. Take the Voyager missions, for example. Launched in 1977, Voyager 1 and Voyager 2 used gravity assists from multiple planets to gain the speed necessary to travel to the outer reaches of our solar system and beyond. These assists allowed the Voyagers to visit Jupiter, Saturn, Uranus, and Neptune, providing humanity with the first close-up images of these distant worlds. Another notable mission is the Cassini spacecraft, which used gravity assists from Venus, Earth, and Jupiter to reach Saturn. This complex series of maneuvers allowed Cassini to enter orbit around Saturn and deliver stunning images and data for over 13 years. Without gravity assists, such an extended mission would have been impossible due to fuel limitations. Looking ahead, the future potential of gravity assists is incredibly promising. As we set our sights on more distant targets like the moons of Jupiter and Saturn, gravity assists will continue to be a crucial tool. The upcoming Europa Clipper mission will use gravity assists from Earth and Mars to reach Jupiter's moon Europa, where it will search for signs of life. Moreover, as we plan for interstellar travel, gravity assists could be used in combination with other propulsion methods to achieve the high speeds necessary to reach other star systems. By slingshotting around our sun or even other stars, future spacecraft could gain the velocity needed to traverse the vast distances of space. In conclusion, gravity assists are not just a clever trick. They are a fundamental technique that has revolutionized space travel.